Hi, this is example 13 of partial differentiation. Suppose z is a function of x and y, where z equal to square root of xy plus y, where x equal cosine theta, y equal sine theta. Find dz d theta when theta equal pi over 4. First of all, we know that z eventually is a function of one variable theta. Therefore, we can find dz d theta. Now, z is also a function of two variables x and y. So, partial differentiation is involved. We can use a chain rule. Okay, the chain rule say that dz d theta equal to partial differentiation of f with respect to x times dx d theta plus partial differentiation of f with respect to y times dy d theta, because x and y depend on only one variable theta. Note that the use of normal differentiation and partial differentiation. We use partial differentiation because the function depends on two variables. We use a normal differentiation because x and y and z depend on theta only, where the function fxy equal to square root of xy plus y, which is equal to xy plus y power half. Let's compute the partial differentiation first. F of xy equal to xy plus y power half. So when I do the partial differentiation, we bring down the power, then xy plus y power negative half. And then you have to differentiate xy plus y with respect to x, which is equal to half times square root of xy plus y times y. So, which is equal to half y times square root of xy plus y. Notice that when you do partial differentiation with respect to x here, we keep y constant. Therefore, differentiate xy, you get y. So, differentiate xy with respect to x, you get y. And differentiate y with respect to x, you get 0. Similarly, we can also partial differentiation with respect to y. We expect the answer to be half square root of xy plus y, and then you differentiate with respect to y, xy plus y. And since x is constant now, so this is equal to square root of xy plus y at the denominator, and then you have, since x is constant, you get x plus y, since dy is 1. And then we also note that x equal to cosine theta, so dx d theta is equal to minus sine theta, and y equal to sine theta, dy d theta is equal to cosine theta. Substituting this information into the expression for dz d theta, you get equal to y over 2 times square root of xy plus y times minus sine theta plus x plus 1 over 2 times square root of xy plus y times cosine theta. And then we put theta equal pi over 4 into sine theta and cosine theta, and x equal to cosine theta, y equal to sine theta, and we evaluate what is the value for dz theta. Substituting cosine pi over 4 is square root 2 over 2, sine of pi over 4 is square root 2 over 2, x equal to cosine pi over 4 is square root 2 over 2, y equal to sine pi over 4 is square root 2 over 2 also, and then you can evaluate this expression. Okay, so you can do a quick way, or you can do a differentiation and check and verify your answer. I'll just use a calculator and find out the answer for you. Okay, in order to find dz d theta, I must replace x by cosine theta, y by sine theta. So z equal to square root of cosine theta times sine theta plus sine theta. Then I use my calculator. Make sure the calculator in radian mode first. You can do a shift, setup, and then angle. Number 2 in radian mode first. Then I do a differentiation. So shift, differentiation, and then enter the square root of cosine theta, cosine x alpha x, then close bracket, times sine alpha x, okay, alpha x, then close bracket again, plus sine alpha x, sine alpha x, close the bracket. Alright, then you move to the right, put in x equal to pi over 4, so you can put a fraction, then shift pi over 4, then equal. So the answer is 0.321797. So that means that dz d theta is 0.321797. Okay, so dz d theta is equal to 0.321797. Let's see again. Alright, at theta equal to pi over 4. Let's finish the recording.